Question number 40. Alpha particles with energy E are directed at nuclei with atomic number Z. Okay, that was Rutherford's experiment. Small deviations from the predictions of the Rutherford scattering model are observed. Okay, which change in E and which change in Z are most likely to result in greater deviations from the Rutherford scattering model. So this is your foil, a gold foil for example, and this is your alpha particle. You make it to pass through it, and most of them in Rutherford's experiment, what happened? Most of them pass straight away like this. Okay, but what he needs, he doesn't want it to be having straight away, but he wants it to have a greater deviation like this. He wants it to have a deviation like this, getting reflected back. When is it possible? So what we do is, when you increase the energy, what can happen? The increase in energy can be made to go nearby to the alpha particles. So these are alpha particles which can be made to increase the speed and can go nearby to it. Okay. So therefore, definitely there is a possibility, because when you decrease the energy, the particle may or may not even go nearby to it, and hence it may fall over here itself. So definitely you need to increase it, first thing. So these two are incorrect. Then what to do with the value of Z? If the value of Z is, for example, in gold particle experiment, you had Z is equal to 79. So as a result of it, some of them went straight, some of them got deviated, and so on. Now let us say if I reduce it, because there are two options over here. If I reduce it over here, if I make it smaller over here, let us say I take something like Z equal to 51 over here. Okay, then what can happen is the electrostatic forces of repulsion of this one will become lower, and as a result of it, this can go much more nearby to it. Okay, so initially with a gold nucleus, the alpha particle was able to go only until this much distance, but with a smaller nucleus, this would be able to go at least until here, much more nearby distance, right? And then it would get bounced off. So interaction would be more in case of when the particle is nearby to this, and hence, so what we can say is when the value of Z decreases, there is a higher possibility that it can get interacted well. But if the value of Z is much higher, if this becomes much larger nucleus, then what can happen? This can come here, the alpha particle can come here, it can get deviated like this. Interaction levels are much less. Okay, so as a result of it, so the answer is B over here. Energy should increase and the value of Z should also decrease, so that the interactions between the alpha particle and the nucleus that you are considering the target metal will increase.